Question 14 is a functions question. It's reasonably straightforward. There should be no catches really. You're given a function, x maps onto x minus 1. Let's just talk about this whole gobbledygook. This here hieroglyphics. G is the function where x is mapped onto x minus 1. So to simplify it to the absolute basic, it's basically saying that the function g of x is equal to x minus 1. Or you could go one step further and actually just say that y is equal to x minus 1. That's basically what that actually says there. So what we're being asked is, let's substitute 3 in as a value of x. So we end up with 3 take away 1, which is 2, and minus 2 take away 1, which is minus 3. Moving on to the next section, we've got a drawing here of a mapping of a certain number of input values and being mapped onto a certain number of output values. So f is the function where 2 maps onto 4, 4 maps onto 6, 6 maps onto 8, 8 maps onto 10. And we can pretty much guess that this, if we were asked what the function was, it's likely it's just add 2, x plus 2, because each time there seems to be 2 more than the input value. So what's the domain? The domain is the input values, what numbers are in that input set. So in this case it's 2, 4, 6 and 8. What is the range? Well, the range is the output values, so it's 4, 6, 8 and 10. And then lastly, the codomain. The codomain is defined as being all those possible numbers that could be used as outputs. Okay, and you can see there's an extra 3 there that's sitting there, and it would be appropriate to not only list the 3 but also the 4, 6, 8 and 10. The range is effectively a subset of the codomain. Now moving on to the last part. This is a little bit more difficult and you have to have wits about you. There's not really much room to actually do workings, so there's nothing wrong with you doing some workings at the bottom or on a separate sheet of paper or on the last page of the paper if there's a space to be able to do so. So let's work through this. We've got you've given a function, so f is a function where where x is mapped onto 3 minus 2x squared. So again, to sort of simplify the function, it's basically y is equal to 3 minus 2x squared. So we have f of 1 and 3 lots of f of minus 1. So the key thing is I need to work out what f of 1 is, and separately then I have to work out what f of minus 1 is. So let's just work those out before we do anything else. So f of 1 is going to be 3 minus 2 lots of 1 squared. And you work that out, we get the answer 1. F of minus 1, we put that into the function, we also get 1. Before I actually move on, I should point out explicitly that when you square a negative number, it becomes positive. Okay, the answer to this here is not minus 1, it is positive 1. Okay, so 3 minus 2 lots of positive 1 is 3 minus 2, which is 1. Okay, if you type in on your calculator minus 1 squared, you will get minus 1. It's not doing it wrong, it's just appreciating that square there is only acting on what's immediately in front of it, and that's the 1. If you wanted, in terms of what we did here, to the correct answer, if you want minus 1 all to be squared, you actually have to put it in brackets on a calculator, and then you'd get the 1, which is what is appropriate and relevant for this question here. So if we now just substitute our answers we got for those two expressions into the sort of calculation we're asked to do, f of 1, which is 1, plus 3 lots of f of minus 1, which is also 1. So 1 plus 3 lots of 1 gives you the answer 4. Moving on to the last part, we're asked to look at f of minus 2. So if we work out what f of minus 2 is, when you work it through, you'll end up with the answer of minus 5. So when I substitute minus 5 into that expression, well, let's think about this. There, f of minus 2 is minus 5. 3 lots of f of minus 2, 3 lots of minus 5, which is minus 15. And it would be safe to say, to appreciate that minus 5 is indeed greater than minus 15, and so therefore the statement's true.